So now in my last video, we made this circuit, which I really like, where we have these LEDs alternating and fading in opposite directions right there. This is the, I added this. We're going to come back to that. But yeah, I got the circuit here. It's a 555 timer in A-stable mode. There's no output, though. We have the capacitor charging and discharging because it's in A-stable mode. Hopefully that makes sense. We have also an op amp. I'm using an LM358, one of the two on the integrated circuit right there, wired as a voltage follower. So it's looking at the voltage of the capacitor right there as it bounces between 1/3 and 2/3 of the supply voltage. I'm using 5 volts right there. Since it's wired as a voltage follower, because we have direct negative feedback, the output's going to make the, since we have that negative feedback, the output's going to be the same voltage as the non-inverting input, which is the capacitor, as I said before. So as the voltage goes down, that LED is going to get brighter. As the voltage goes up, that LED gets brighter. As one gets brighter, the other one's going to get dimmer. So just kind of a quick review right there. If that's a little bit confusing, first thing I can do is stop right there, their voltage. The pin number 2 doesn't see the voltage anymore, so it's not going to kick into effect. We're not going to worry about that too much. So yeah, I'm going to pluck those 2 jumpers. Now I'm going to, so that's the non-inverting input, that's where that jumper was going to. None of this circuitry now is affecting this at all. The output there just locked in place. I'm going to take this jumper, go to the non-inverting input, and instead we're going to get our signal voltage from this trim pot right there. So the output is high right there. It's 5 volts. And if I want to get to more of a range that we had before, there we go. Now it might be even be a little bit easier to see the LEDs. So right there, that was one of the extremes that we had. And down here to 1/3 of the supply voltage, pretty close to that. We have the other extreme right there. I don't think the LED ever fully turned off, but it came close right there. So yeah, we can simulate that with the trim pot right there. And I just felt like doing a bonus video of this because a lot of the things I demonstrate are with a trim pot where you can change the voltage as you desire the signal voltage. Again, the op amp is just looking at the voltage there, not drawing any power from this, although a little bit of current might trickle through. It doesn't depend on that. It's just looking at the voltage and responding to it, the input. And this is another example of why we have the trim pot. It's just setting a voltage somewhere. It might have to provide a little current, but generally you try to not have to provide any current. The more current you got to use or provide, the lower value trim pot. This is a 10K trim pot, 10,000 ohm trim pot. And if you want it to maintain a voltage, well, it provides some current, you got to use less resistance. But when you're using an op amp, probably 100K trim pot would work just as well. Maybe even a 1,000,000 ohm trim pot might work just as well. Then again, this may be leaking enough current where it could throw the voltage off. So yeah, not a big exciting thing, but I think this will be helpful for some people realizing what my trim pot is doing. All I'm doing right now when I do this is simulating the charge and discharge of that capacitor in the 555 timer circuit when it is in A-stable mode. It just keeps bouncing back and forth between 2/3 and 1/3 supply voltage between the two, just as if I constantly turn the trim pot like this. We get that effect. And so we got the voltage going up and down to 2/3 and 1/3 of the supply voltage. We're just kind of simulating what the capacitor does. A lot of times you do that while you're building prototype circuits. So at least that's what I do. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.